Hello everyone, good evening and welcome to the ninth week of the live interactive sessions for the course Integrated Waste Management for a Smart City. And I'm Sedi Vinayaga, a PhD scholar in the Civil Engineering Department at IIT Madras. In this week, the lectures talked about landfills and landfill disposal. So, towards the end of the previous week, the landfill disposal concept was introduced, and then we continued with that discussion in this week. So, in the first lecture of this week, we looked at the leachate collection system and how the leachate quality changes with the age of the landfill, right? And then in the second lecture, we looked about once we collect this leachate, how do we treat it, right? Because we cannot directly dispose it away because it can contain some contaminants that were present in the landfill, the waste in the landfill. Therefore, we need to treat it before we dispose this leachate, right? So we looked at that, and then there will also be some gas production. Yeah, yeah, in addition to the leachate, there will also be some gases which will be produced, and so we looked at that aspect as well. And then in the third lecture, we looked up at a concept called a bioreactor landfill. So this bioreactor landfill is a way of accelerating the anaerobic reaction that takes place in a landfill, so that whatever gas that is produced and the leachate that is produced will be produced in a faster at a faster rate, so that we can get all the useful gas that we can get out of it, such as methane, in a shorter period of time. We don't have to wait for a long period for this landfill to mature and stabilize before we can before we can close it for good, right? So that was the bioreactor landfill, and then we also then started looking at some of the basic landfill operations. And then in the fourth lecture, we looked at landfill sizing and the volume calculation. So given a so because these landfills do not have a rectangular or a square shape, so it is going to have some trapezoidal shape. So we looked at how do we what should be the size of the landfills, and once we decide that, how do we know how much this landfills can how much waste can these landfill take. So we need to know the volume of the landfill as well, right? So we looked at some calculations with respect to that, and then we moved on to the facility siting. So we need to find a location where we can have this landfill. We can't have this in the middle of the city because that's going to cause several issues, right? So because it has odor issues and aesthetic problems and other things, so we need a proper siting, a proper location for this landfill. So we looked at the basics, and then in the last lecture we looked at some an example of this process that we go through to find this appropriate site and also to get the permissions, right? So appropriate permission. So we looked at an example of that process. So that's what was covered in week 9. So with respect to these concepts, we'll look at some of the questions. So the first question is, help is based on dash model. The options are energy balance, water balance, momentum balance, and heat balance. Okay, so what does HELP stand for? So HELP, if you expand it, it's a hydrologic evaluation of the landfill performance, right? So what does that mean? So we are designing a landfill, right? So when we are designing a landfill, leachate collection system is one part of it, right? So how do we design this leachate collection system? To do that, we need to know how much leachate will be produced from this landfill, right? So this HELP model, or the hydrologic evaluation of the landfill performance, is a model that tells us or gives us an estimate of how much leachate we can expect from a given landfill, right? So that's what this model is. But what it works based on option B, a water balance model, right? So what do we mean by this water balance model is, say if we consider this schematic, simpler schematic, where this orange portion represents our landfill. So how do we get the leachate? So one source is the rainwater, right? So the precipitation, so that supplies water. So we get the rainwater, so that is the input, and part of this rainwater will be leaving as surface runoff, that is R, right? So it will never get into this landfill, it will just leave as runoff water, and then some water will be retained at the top layer itself, right? So that will be taken up by the vegetation that is present on the cover soil, right? And then it will be leaving back into the atmosphere through the evapotranspiration process. So whatever was left will be percolating into the landfill, and this some part of it will be leaking below the landfill, right? But which is not desirable or ideal, but it is possible that there can be some leakage, and then whatever is left should be the leachate that is coming out of the landfill, right? So by when we collect data about all these different components and do a balancing, we will be able to estimate how much is the leachate that will be coming out of this, right? So this estimate is necessary so that will be able to design our leachate collection system for the landfill, right? So that is what the health model is based on. It's a water balance model. Okay. Any questions? All right. So moving on to question number 2. The pH is minimum in which phase of the landfill stabilization stage? The options are methane forming, acid forming, preliminary aerobic, and final aerobic. Right. So we looked at different stages of landfill stabilization. Right. So they are given here, but not in the right order. So if you put them in order, what happens is we start with the preliminary aerobic phase. Right. As the name says, preliminary, it happens at the start. So we start with an aerobic phase because the landfill, when we start filling up this landfill, it will be open for some time, right? And there will be some unfilled space as well. So all this space will be filled with air, right? So that promotes the aerobic decomposition at the start of this landfill, right? So when it is young or at the start. Once this preliminary aerobic phase is done, so we go into an anaerobic phase, which is the first of, there will be two anaerobic phase, the first of which is the acid forming phase, right? So in this acid forming phase, the anaerobic decomposition takes place, where the organic matter will be converted into higher into acids, right, such as acetic acid. And once this stage is done, we move into a methane forming phase, where the acid formed will be converted into methane. And finally, we'll also finally end up with again an aerobic stage, which is the final aerobic stage. This is because there will be, once this acid and methane forming phases are done, the volume of the landfill will reduce, because the organic content is being degraded, right? So this, and then some air can intrude into those volume, and then we'll again can have a final aerobic phase as well, right? So out of these four phases, we want to know when the pH is minimum, right? So as the name suggests, this acid forming phase is going to produce more and more acids, right? And therefore, that is when we expect the pH to be minimum, right? So we, as we see here from this graph, so during the acid forming phase, the pH is minimum because of the acid production, right? So out of all the four stages, this is when the acid concentration is higher, and therefore the pH will be much lower compared to the other stages. Therefore, the minimum pH will be in this acid forming phase. Okay, any questions? Okay, so moving on to question number 3. Which of the following is a physicochemical treatment process of leachate? Right. So the options are chemical oxidation, activated sludge process, oxidation pond, and wetland treatment. Okay. So in this question, we are concerned with physicochemical treatment. So what do we mean by a physicochemical treatment? It's either a physical process, right? So it should involve some physical treatment or a chemical treatment. So physical treatments, that means the physical properties should be altered, right, in such a process, or the chemical structure should be altered, right? So those processes which alter the physical property or the chemical structure, those are called the physicochemical processes, right? So we need to find out which of these is the physicochemical process. So out of these, the activated sludge process, oxidation pond, wetland treatment, these involve some biological treatment process, right? So we use the microorganisms such as bacteria and those things in all these three processes: activated sludge, oxidation pond, as well as the wetland treatment. Either a microbial activity or some so for example, in this wetland treatment, we use some aquatic plants as well, which will help in the destruction of the organic matter, right? So these BCD or biological process. So which leaves us with option A, which is chemical oxidation, which is actually a chemical treatment process, which is an advanced treatment of oxidation, right? As opposed to a biological oxidation. In a chemical oxidation, we use chemicals to accelerate to do the oxidation process. So therefore, option A is a physical chemical treatment process. So whereas we looked at other examples during lecture, for example, adsorption. So adsorption, ion exchange, membrane filtration. So those can be physical processes. Sorry, adsorption and membrane filtration can be physical process. Whereas coagulation, chemical oxidation, ion exchange, these can be chemical processes, right? So these are the physicochemical treatment process that we can use to treat the leachate. Okay, any questions?
Sir, what does physico-chemical mean,
Yeah,
sir?
so it's either a physical process or a chemical process. So, for example, we have adsorption here, right? So adsorption makes use of a physical property, right? So when a substance is getting adsorbed onto the surface of another substance, so that is the adsorption process. So that is a physical process. Similarly, filtration is also a physical process, right? For example, the reverse osmosis, nanofiltration. So these are based on the physical properties. On the other hand, coagulation, so that is when you lump where the smaller particles get lumped into bigger particles, and then they will flocculate, and then they will sediment to the bottom of whatever is the container, whatever it is. So that is coagulation. That is a chemical process. We add some chemicals to make that happen. So that we make use of the chemistry. So either we use of the physical property or the chemical structure to treat the leachate. So if it comes under either of this, then it is a physico-chemical process. Whereas the other options listed here, activated sludge, oxidation, and wetland treatment. So these make use of biological processes, right? So therefore, it does not come under the physico-chemical.
Okay, thank you, sir.
Yeah. Okay, so moving on to question number 4. Match the following leachate treatment process effectiveness for a landfill. So we have two columns. So the first column tells us the type of leachate that we have, whether it is biodegradable or an intermediate produced from an intermediate landfill stage or from a stabilized landfill. And then we have the effectiveness of the adsorption process, whether it is good or a fair to poor effectiveness or good to fair effectiveness. So we need to match the type of leachate to what to if you use an adsorption process to treat this leachate, what will be the effectiveness with respect to the leachate type. Okay, so we'll do a poll for this, so you can take a minute to think about it. So what will be the effectiveness of this process for that leachate type, and then answer that. Okay, we have one answer, which is option A. We'll wait for others a couple of minutes. We'll give them a couple of minutes. Okay, two answers say it is option A. Any other answers? Okay, so we have three answers. That's option A. And option A is the correct answer. Right. So biodegradable leachate type will have the adsorption process will be fair or very poor for treating such type of leachate, whereas for the intermediate type of leachate, the adsorption process will be good or fair. Whereas for the stabilized leachate, it will be a good option. It will have a good effect when we go for the adsorption process. So that is given an option A, the right match. So why does that happen? Because when the landfill is young, right? So when it is 5 years or lower, the leachate is going to be having more organic matter, and therefore it will be more biodegradable. As the landfill ages, right? So when it becomes 5 to 10 years or more than that, so the amount of biodegradable material is going to become lower and lower, right? So therefore, any biological treatment, right, so that will be more effective at the starting period of the landfill, and that will become a less and less effective because the biodegradable content will be getting lower. So in therefore we need to go for the physical or the chemical treatment process, as we saw earlier. So adsorption is one physical process. So when there is more biodegradable material, it is not going to be that effective, whereas as the landfill ages, so this physical process will be more and more effective, right, as opposed to a biological process. Therefore, we go for this option A, which is basically tells us as the landfill ages, it's going to become more and more suitable for an adsorption process. Right. Moving on to question number 5. Which of the following is a non-combustible landfill gas? So the options are carbon dioxide, hydrogen sulfide, methane, and none of the above. Okay, so here we are talking about combustion. So what is combustion? Combustion is an oxidation process, right? So an element combines with oxygen. That's what is the oxidation process. That's what happens during combustion. So if you look at the three of the landfill gases, right? So most prominent ones, so the carbon dioxide, hydrogen sulfide, and methane. So out of these three, carbon dioxide, if you look at it, it is already in an oxidized state, right? So carbon has already combined with oxygen to produce carbon dioxide, right? So it is already in a stable oxidized state. So which means it will not undergo combustion again. On the other hand, hydrogen sulfide and methane both are combustible. They have potential to be oxidized, right? If the conditions are right. So if there is oxygen present and there is you provide an ignition, so they can combust and then get oxidized, right? Whereas carbon dioxide is already in an oxidized form. Therefore, out of these options given, carbon dioxide is the non-combustible gas because it's already oxidized. Right? Therefore, the right option is option A. Okay. Question number 6. Which of the following is a social issue associated with landfill construction? The options are increase in economic activity, reduction in property values, contamination of air, and none of the above. Right. So we have some options. So we need to classify out of these which will fall under a social issue. Right. So a landfill can have a variety of issues, can create a variety of issues, right, with respect to environment, with respect to social, legal, and so on. We need to know which of these is a social issue. So option A says increase in economic activity, right? So which is not an issue, right? So when economic activity increases, it's desirable. It's not an issue at all. And option B says reduction in the property values, right? So why does that happen? Because landfill, as we know, it's going to produce landfill gases which are which has odor, right? So which is not desirable, and it will also produce leachate, so which, if not properly designed, can leak and affect the groundwater or even the surface water as well, right? So there is contamination issues. And also this landfill has to be operated, so there will be these garbage trucks that will be routinely delivering garbage to this site, right? So there will be a lot of those garbage truck activities going on, and there can also be littering of these waste around this or nearby this landfill site, right? So the aesthetic value of this around this area will be going down, so that will reduce the property value around in the vicinity of this landfill site, right? So that is not desirable by the people who are going to be who are going to own the land in that area or living there, right? Because they don't want their property values to be affected. So that is actually a social issue. Whereas contamination of air, so that is a environmental issue, right? So we don't want that, but it comes under environmental issue. So out of these options, so the reduction in the property value is a social issue. So in addition to that, there could be other issues which can also be social, which is the disruption of the quality of life. Again, you don't want to live near a place that is having odor, or as I said, which can also contaminate the groundwater or the air. And environmental justice, we want everyone to have access to clean water and so on, right? So we don't want some people to be affected. And also there are some historical sites, cultural sites, archaeological sites. So those can also it is not desirable to have a landfill site near them, right? So these are all social issues that can occur when we are looking for a landfill site. Okay, question number 7. It's a numerical question. So calculate the landfill's capacity if the solid waste is accepted at a rate of 10 tons per day and the density of the waste in the landfill is 500 kilogram per meter cube, and the volume of the landfill is 150,000 meter cube, right? So the options are 20.55 years, 30 years, 25 years, and 50 years. Okay, you can again take a minute or two to solve it, and you can answer in the poll. Okay, we have one answer, option A. We'll wait for others to also solve it. Any other answers? Okay, so let's take a look at the answer. It is 20.55 years is the correct answer. So let's see how do we arrive at that. Okay, okay. So we need to know what is the landfill's capacity. So what do we mean by the landfill's capacity is, it is, so we have a particular volume, right? So it is 150,000 meter cube, right? So that is the amount of volume that we have where we can put our waste, right? So how long will it take for us to fill this volume, right? So once we fill this volume, we can't add more waste to it, right? So that's what we call it as a capacity. How much waste can it take, or how long will it take for it to be full, right? So how long will it take to fill this 150,000 meter cube, right? So how can we find that out? How long will it take? So the capacity is nothing but the total volume over the rate of filling it, right? Rate of filling. So we have some volume that is available, and if we know at what rate we are filling this volume, so we will be able to find out how long will it take for us to uh, uh, how long will it take for us to fill that total volume, right? So out of this, we know the total volume that is given to us. So we need to find out this rate of filling that is also given to us, but it is given in terms of the weight, right? So we know 10 tons of waste is getting added in one day to this landfill, but we need it in terms of the volume, right? So this rate of filling should also be in volume, right? Only then we can get the capacity in time units, because then the volumes will get cancelled, right? So let's try to get the rate of filling in terms of volume, right? So rate of filling is given as 10 tons per day, right? 10 tons per day, so which is the same as saying 10 times 1000 kilograms per day, right? So 1 kg is 1000, one ton is 1000 kilograms. So 10 into 1000, that is the amount of waste that is getting added in kilograms per day, right? So if you want this in terms of volume, we need to divide this by the density, which is also given 500 kilograms per meter cube. So if we divide this mass by the density, we will get it in terms of volume, right? So that is 10 times 1000, right, divided by 500 kilograms per meter cube. So that we will get as 20 uh, meter cubes, right? So 20 meter cubes per day. So this is the rate at which we are filling the landfill, right? So we have 10 tons per day, which is 10,000 kilograms per day. If we divide that by the density, which is 500 kilograms per meter cube, we will get 20 meter cube per day, right? So that is the rate at which we are filling the landfill. So now we have the information to get the capacity, right? So now if we calculate capacity, so which is 150,000, right? 150,000 is the total volume divided by 20 meter cubes, right? Just let me reduce the size. Okay, right? So that will give us the capacity. So this would be 7,500, right? So 7,500, the units is days, right? So we are dealing with only per day values, per day rates, right? So this will give us 7,500 as the capacity in terms of days, but the solution or the answers options are given in terms of years, so we need to convert it, right? So 7,500, if we divide that by 365, so that will give us in terms of years, so that is approximately 20.55 years, right? So if we fill 10 tons of waste per day, it will take us 20.55 years to fill the whole landfill, right? So therefore the capacity of the landfill is 20.55 years. Okay, is that clear? Okay. Okay, then let's move on to question number 8. Okay. Question 8 is, what is the minimum period of the post closure care of a landfill? So the options are 10 years, 20 years, 30 years, and 25 years. Okay, you can either answer in the chat or in the poll. We have one answer, option C. Okay, we have a couple more answers, all saying option C. Yeah, so the right answer is 30 years, right? So what is this post closure care? So once we saw the capacity, right? So in the previous question we said it will take 20.55 years if we dump 10 tons of waste every day. right? So once, let us say, we reach the 20.55 years and we have filled the landfill, right? So the landfill is now full; it can't accept any more waste, right? So we have to close this landfill because we can't dump any more waste in that, right? So once we close the landfill, we can't just leave it like that, because we know the landfill is going to because there is going to be anaerobic degradation of this waste taking place, and that will be generating the gases as well as the leachate, as we saw earlier, right? And therefore we need to keep monitoring this landfill, right, for some period of time, so that and until this process stops, until we don't get any more gas and leachate from this landfill, we need to make sure that these are not contaminating the environment, right? So we need to monitor it for some period of time until these anaerobic processes stop, so that we can be sure that we are not affecting the environment, right? So that is called as the post closure care, right? So we need to keep monitoring this landfill for a certain period of time, so that we are not affecting the environment. So that period is called the post closure care, and typically, right, as the EPA standard says, for a municipal waste, it is 30 years, right? So that is a typical period, but it is not a very strict value. Like, depending on the field conditions, it can be either reduced a bit or it can be increased a bit as well, depending on the type of waste and the local conditions. It can be adjusted, right? But typically it is at least for 30 years we need to be monitoring this site, right? So what do? We just collect samples of the groundwater around this place, right? So, and then see what is the level of if there is any contaminant present in it, right? So we do that at frequent intervals. So that's the post closure care, and it is typically for 30 waste for a municipal solid waste. Okay, question number 9 is sanitary landfill, which operates by recirculating the leachate back to the landfill to accelerate the decomposition, is called dash. The options are bioreactor landfill, engineered landfill, activated landfill, and none of the above. So, what is the term that we use for a particular type of landfill where we recirculate the leachate back into the landfill? So, the landfill produces leachate, we take it, put it back into the landfill. Okay, we have one answer, option A. Any other answers? Yeah, another answer also says option A. Yes, so the correct answer is option A, bioreactor landfill, right? So that's the definition of a bioreactor landfill. So it's a sanitary landfill where, to accelerate the decomposition process, we recirculate the leachate that we get from it back into it, right? So why do we do that? Because this anaerobic decomposition, it requires some moisture, right, for the bacteria to decompose the organic matter, right? So where do we get this moisture from? One is we saw from the health model. So some rainwater may also percolate into it, and then we can get that. But because we are closing off this, so that may not be providing enough moisture, right? So moisture content will keep going down. So therefore actually use this leachate that is coming out of this landfill to add back into it, right? So we don't want to waste any fresh water, right? So we don't want to do that. So this leachate is also having some moisture. So why don't we use that instead of going for a pure water or fresh water, right? So that's the concept behind it. So that is going to help us in the decomposition process, right? So it is going to accelerate the process. So that's what we call as a bioreactor. We also looked at engineered landfill. So that is basically for uh, a landfill which is designed to keep the leachate from leaking into the groundwater, and also not letting the gases directly into the atmosphere, right? So that's what is an engineered landfill. We use the liners and also a cap to seal it, right? So that's what is an engineered landfill. Whereas a bioreactor landfill is where the acceleration of this decomposition takes place by recirculation of this leachate. Okay, so that's the difference. Okay, so question number 10 is, what are the different methods of leachate management systems? Options are evaporation of the leachate, leachate recirculation, direct disposal onto the land, all to offsite for treatment. So, which of these methods can we use to treat or manage the leachate? And so now we are looking at multiple select questions, so more than one option can be correct. Okay, A, B, C is one answer. We have got okay, A and B, B and D, okay, B and D. Any other answers? Okay, A, B, and D. Okay. Okay, so let's look at the answer. So the right options are A, B, and D, right? So other than C, all the other three are methods which we can use to manage the leachate, right? So evaporation, so we can evaporate it, so the moisture will be released, and then with the reduced volume, we can manage it better, right? So evaporation can help us to manage the leachate. Leachate recirculation, we just looked at bioreactor landfill, right? So this is one way in which we can manage it. So we don't have to treat it, just put it back into the landfill. That's going to help us in accelerating the decomposition, right? So whatever comes out later, so we can treat that again, right? So recirculation is one method. C, we will come back to it. D is haul to offsite for treatment, right? So either we can do a treatment of the leachate that we are getting it on the site, or if there is a wastewater treatment plant nearby, so we can send our the leachate from our landfill to that site, which can handle it for us, right? So that is what is haul to offsite treatment. So that is also possible, right? So all those three options are ways in which we can manage it. See, says direct disposal onto land, which is not a method of treating it, right? So which is actually doing nothing. Okay, so what happens if we just dispose it directly onto the land without doing anything? It will get into the soil, right? It can find its way to the groundwater and then contaminate the groundwater, right? Or if you just leave it on land, if it rains, so it's going to mix with it. It's going to become a part of the surface water, and then it will affect the surface water as well, right? So which is why we are collecting it in the first place, right? We are using the liner system so that it doesn't percolate into it. Is because of this reason. We don't want it to affect the groundwater, the surface water, right? So if we do it, if we directly dispose it onto the land, so that defeats the purpose of collecting it in the first place, right? So we don't want to do that. So that is not a way of managing the leachate. So other than that, all the other three options, A, B, D, are ways in which we can handle the leachate. Okay, so question number 11 is, which of the following is a property of landfill gas? So the options are non-toxic, greenhouse gas, potential energy source, explosive. So we have multiple gases are produced from a landfill. So which of these can be a property? It could be a property of just one gas or multiple of them, but which of these are properties that we see from landfill gas? Okay, we have one answer. Option C, option B, C, options all the options A, B, C, D. Okay, C and D. Any other options? Okay, so let's take a look at the answer. It is options B, C, and D. Right? So we know carbon dioxide, methane, they are greenhouse gases, right? So methane, a potential energy source, right? We can use it for generating. We can combust it and produce heat from it, right? It's a potential energy source, and also methane explosive. It's combustible as well as explosive. So is hydrogen sulfide, right? So that is also explosive. Whereas these are not non-toxic. So these landfill gases are toxic, right? So for example, hydrogen sulfide, it's a toxic gas, right? So therefore, option A is not right, whereas options B, C, and D are properties of the landfill gases, right? So all the three are correct. Okay. Question number 12 is landfill gas contains which of the following gases? Options are oxygen, hydrogen sulfide, methane, nitrogen. So again, as I said, landfill gas means it contains a variety of gases, not just one. So which of these are part of the landfill gas? Okay, B, C, and D. Okay, all the options so far says B, C, and D. Any other options? Okay, so let's look at the answer. It's actually only B and C. Oxygen and nitrogen are not part of the landfill gas, right? So it is. So when we say landfill gas, it's what is produced as a part of our as a part of the decomposition process that happens, right? So it's what's produced by the landfill. So oxygen is not produced, it lies. Nitrogen is also not produced as a process, as a part of the anaerobic degradation that happens, right? So it's only the, out of the options given here, it's only the hydrogen sulfide and methane. So in addition to that, there will be other gases, so which are carbon dioxide, there could be some water vapor, some non-methane organic compounds, and some cases there could be some presence of some heavy metals which are volatile as well, right? So but nitrogen and oxygen are not part of the landfill gases, right? It's not produced as a part of our landfill decomposition process. Okay, so question number 13 is what are the different environmental issues associated with the landfills? Options are contamination of water, improvement of tourism, contamination of air, and destruction of sensitive lands. So we looked at social issues earlier. So here we are looking for environmental issues. I think this is pretty obvious, right? So, okay, ACD, AD, right? Any other answers? All right. So the right answer is options A, C, as well as D. Right. So we know we talk a lot about this, right? So contamination of water. It's not whether we have to do it or not. So it is possible, right? So if we don't have an engineered landfill, right? So or even if with an engineered landfill, sometimes it is possible that there could be some leakage, right? So that can lead to contamination of water, the groundwater, or even surface water as well, right? So that is an environmental issue. Improvement of tourism, it's not going to improve tourism, right? And also that is not an environmental issue whether it's going to improve or decrease the level of tourism. So we are not concerned about that as an environmental issue per se, right? So that we can eliminate. Contamination of air, again, the landfill gases, if we are not managing it properly, could potentially contaminate the air. And the final one is destruction of sensitive land. So based on where this landfill is sited, right? So based on its location, it could lead to destruction of sensitive land, such as if we are putting it in some unique habitats, right? For some species. So if we could end up destroying those sensitive lands or any wetlands, right? So by contaminating them, right? So it could lead to the destruction of sensitive land, which is an environmental issue, right? So all the three options A, C, and D are issues concerning the environment. Okay. So question number 14 is, which of the following are the different aerobic leachate treatment methods? So the options are upflow anaerobic sludge blanket reactor, sedimentation, aerated pond, sequencing batch reactor. So which of these are aerobic processes for treating the leachate? Okay, A and C. Okay, C and D. Okay, C and D again. Any other answers? Okay, so let's take a look at the correct answer. It is C and D, right? So think the two options out of these four are pretty clear from the name itself. So option A is an anaerobic process, as the name suggests, right? It's a flow anaerobic sludge blanket reactor. That's clearly not an aerobic process. C, as the name says, it's an aerated pond. So it's an aerobic process. So you can be clear about options A and C. So A is not an aerobic process, whereas C is an aerobic process. So out of B and D, sedimentation, again, it's not a aerobic process. We don't need oxygen for sedimentation to occur, right? So it's through gravity. So sedimentation is eliminated. So the remaining one is option D, sequencing batch reactor. So the sequencing batch reactor is actually a type of the activated sludge process. So we use some microbial flop along with oxidation or supply of air. So to do this activated sludge process, it is one type in which we could do that. So that is the sequencing batch reactor. So it is also an aerobic process, right? So of the four given options, option C and D are the aerobic processes that we use for leachate treatment. Okay, any questions? Okay, so this was the last question for this week. So if you have any questions, you can ask. Otherwise, we can wrap up the session. Okay, if you don't have any questions, you can feel free to log out. Okay, thank you for attending, and we'll meet again next week.
Thank you, sir.
Yeah, thank you.